this is my demonstration of how to do a paired t-test analysis. I think this is actually the first one of these that I've shown, but what we've got in all of these example analyses is as much as possible on one screen. Generally speaking, here on the left-hand side, the leftmost columns are going to be where you're going to put your data in, and then everything over here is going to be calculations. Now there might be a few places over here where you have some inputs, and I could make those a little clearer, but we'll talk about this in a second. So a paired t-test is a situation where you have made the same measurement 2 different times on the same individual. So you've got well, actually, it doesn't have to be the same measurement, but a similar kind of measurement. So you could have a heart rate before and after exercise. You could have the finger length on the left hand and the right hand, which is what we do in the lab. You could have how much time my kids spend on video screens before schools were closed down and after schools were closed down. It's a lot of before and after. It doesn't have to be, but it's usually before and after kind of stuff. So you have those 2 variables, and then a third variable is computed for you. So you take this one minus this one, and that'll give you the change. So that it matters what order you put it in. You want the change to reflect the way that makes sense. So in this case, after minus before will give us a positive if it increased. That went going from this way, and a negative if it decreased, like in this one. So then we calculate a bunch of things over here. The sample size, it's the count of how many things are in this column. The mean difference, the average of those differences. Standard deviation and standard deviation function. Standard error, hopefully standard errors and mean are starting to look a little familiar. We have the mean, the standard deviation divided by the square root of the sample size. T-statistic is where you have the mean divided by the standard error. And that mean, it's just a mean because we're always comparing this difference to 0. Because that would be what you'd expect this average difference to be if there was no real difference between before and after other than just sort of noise. And our degrees of freedom here are going to be the sample size minus 1. And again, in this case, the tails would be one-tailed if you expect the difference to be after always bigger or after always smaller, and two-tailed if you don't know whether after is going to be always bigger or always smaller, but you think it might be different from before. And then here's the probability of observing this t-statistic if the true mean difference was 0. And so this is a significant p-value less than 0.05. And then I made some stuff here for the graph. The graph uses this to make its picture. It comes up with some error bars too, which I believe are hidden behind the graph. No, they're over here. This is where the standard error is calculated right there. So that's where it gets the standard errors from. And what do we have over here? Well, we have some stuff for rounding, which is this stuff. We have a little bit for reporting, so we have units for a report over here. How many standard significant digits for the rounding? And then this is just work to put together, just like this is for this final boilerplate. So we can see the change from before to after was significantly different from 0. And it'll compute that for you. So you can copy that and paste in your report. Maybe turn that into a subscript. You'll be ready to go. So hopefully that helps. So anytime you have a before or after thing, I'm asking you, was there a change when the thing was measured on the same subjects? You paste the before in here, the after in here. You only had like 14 data points. You'd want to make sure you got rid of all these differences, because that would be awkward. So now the sample size is correct, whereas before it wasn't correct, right? So we want to get rid of those. Good, then it works it out correctly.